The biggest challenge of learning networking is the fact that, well, networking is incredibly complicated today. Now, complicated is good. Complicated means convenient. For example, I could fire up my iPhone and I can get right onto the internet and check the traffic, whatever I need to do. My TV in my house is connected to the internet and I can do Netflix and all kinds of cool stuff. Even in my house, the electric meter on the back of my house is connected to the internet. So networking today, because of the internet, is fabulously complicated. Well, complicated is good, but it's not a good way to learn about networking. So to appreciate networking, what I want to do is simplify things a little bit. Let's go back in time. And to do that, I want to show you these old guys here. This is a NIC, or a network interface card. Traditionally, these are plugged into individual computers, and then we use this big chunk of cable right here to connect to a box, which at least for the moment, I'm going to call a hub. This box acts as the interface to allow lots of computers, well, at least in this case, 8 computers, to interconnect with each other so that they can share resources. Now, when I say share resources, a resource can be anything from a web page to a Microsoft Word document to a LAN server playing World of Tanks. It doesn't really matter to me, but it's just something that somebody can share with somebody else. As a matter of fact, because this is only local, this is where the term local area network came from. We'll develop that more in other episodes in this series, but for now that'll work. Now the thing is that if I've got all of these computers connected to each other, how are they actually sending data? If I've got one computer with a Microsoft Word document and I've got another computer where that person wants to access that Microsoft Word document, how does the data actually move through all these little cables? Now, to appreciate how that works, you have to go back a little bit and understand that we're talking about binary data being sent. Now, I don't care if it's a copper cable with electricity going up and down, or if it's a fiber optic cable with light turning on or off, or even if it's a wireless network where radio frequency basically says on and off, it's always ones and zeros on and off. So if you really want to see data being moved along these cables, it looks kind of like this. Wow, that's really good there. The idea is that it's kind of like a Morse code that's being sent between devices. And these devices understand that code, and they can actually do things with it, like recreate a Microsoft Word document or whatever it might be. Now, the thing you really need to appreciate, and this is the cornerstone of everything that's networking, if there's one thing I'm going to make sure you understand before you run away, is that this data is not sent in big, long, continuous streams. It's sent in discrete chunks that are called, traditionally they're called frames, although you hear the word packets as well. And again, there is some difference, and in other episodes in the series we'll qualify that. So if you really want to understand what's going on, what I need you to do is visualize discrete chunks of ones and zeros that are flying back and forth across your wires on your network. So they look, if you want to see what a frame looks like, it looks something, well, kind of like this. These big stream of ones and zeros that are running across the screen, now notice that they start and then they stop and then another chunk comes along and another chunk, are what frames really are. And we call this packetized data. So in order to appreciate packetized data, and trust me, packetized data is the cornerstone of networking, we need to do something to analogize the concept a little bit. And, well, I like to play, so let's use some blocks. Yay, fun blocks to play with. Now, this block is going to represent a frame. So let's bring our frame back here. Okay, now, if you take a look at this frame, you'll notice it's all the ones and zeros like we saw before. Now, the thing you need to appreciate is that a single frame can be up to 1,500 bytes long. So if there's 8 bits to a byte, so that would be just around 10,000 ones and zeros to represent one single frame. So if we scale this down a little bit, yeah, you can't even see the ones and zeros. So because frames are relatively long, so that's just how they show up. And that's part of why we use these little blocks to represent individual frames. So a frame is actually generated inside the network card. Data comes down from whatever applications, Microsoft Word or web browsers or whatever it might be, comes down into the network card itself. The network card creates the frame and shoots it out into the network. Equally, frames are eaten up by network cards. As a frame comes into a network card, the data is pulled away, sent up to whatever software needs it, and then it's actually wiped out within the network card itself. So, to appreciate a frame, what we need to understand is that we use blocks like this as a representation. Frames are always going to be a maximum of 1,500 bytes, and they have a discrete beginning and a discrete end. And remember, frames are created and eaten up within the network card itself.